Hi, Mr. Wright here, and welcome to this film, which is the film which accompanies my Summer 2025 predictions film. Now, the Summer 25 predictions film is a film which contains details of all of those topics which have appeared in at least 2 out of every 3 IGCSE Edexcel past papers. If you haven't seen that film, there's a link to it right here, so perhaps click on that link and watch the film before you watch this one. Now, this film contains the work solutions for all of those questions which I use as examples in my predictions film. You can download the questions by clicking the link in the description of this film, and my suggestion is that you download the questions, have a go at the questions, and then compare your solutions with mine. Watch the film through, comparing your solutions with mine. Of course, if you're stuck on a question, you can watch that part of the film and work alongside me as I work my way through that particular question. If you've got any questions, please do leave them in the comments, and of course I'll respond. If you find the film useful, please tell me in the comments, give me some positive feedback, and of course, if you're preparing for your Edexcel IGCSE Maths exam, please do subscribe to the channel. There's lots on here to help you. Right, click on the link, download the questions, and I'll leave you to crack on with those. Good luck with the maths. Gladys buys a table for $465 to sell in her shop. She sells the table for $520. Work out the percentage profit that Gladys makes on the sale of the table. Give your answer to 3 significant figures. Right. So she buys for $465 and she sells for $520. So let's work out the profit she makes first. 520 minus 465. She makes $55 profit. So to work out the percentage profit, I'm going to put the profit over the original and multiply by 100. That gives me an answer of 11.8279 and so on. And I'm asked the answer correct to 3 significant figures. So the answer I would give would be 11.8%. Part B. Gladys has a sale in her shop. She decreases all the normal prices by 12%. The normal price of an armchair was $550. Work out the sale price of the armchair. So we've got $550. And we're going to reduce that by 12%. Well, if we reduce by 12%, we'll have 88% left. So to work out the new price, I'm going to do 550 multiplied by 0.88 to work out 88% of the old price, which means that the sale price is $484. In a sale, normal prices are reduced by 20%. A bag costs 1,080 rupees in the sale. Work out the normal price of the bag. So here's the original price, and that is reduced by 20%. So it's multiplied by 0.8 to give me the sale price, which is 1,080. So if I'm going to go the other way, then I'm going to do 1,080 divided by 0.8 to give me the original price, which is 1,350 rupees. Question 1. A rectangle has a length of 21 centimetres to the nearest centimetre. So that means that the length's upper bound is 21.5 and its lower bound is 20.5, and a width of 5.3 centimetres to the nearest centimetre. So we've got an upper bound 5.35 and a lower bound of 5.25. Work out the upper bound for the perimeter of the rectangle. Well, the perimeter of the rectangle is going to be the length times length plus the width, plus the length plus the width, or twice the length plus the width. So twice length plus width. And if I want the upper bound, I'll use the upper bound for the length, 21.5, and the upper bound for the width, 5.35. So all I need to do is use my calculator to work out 21.5 plus 5.35, and then multiply the result by 2, giving me 53.7 centimetres. Now work out the lower bound for the area of the rectangle. Well, to work out the area of the rectangle, I'm going to do the length times the width, and if I want the lower bound, I'll use the lowest possible length and the lowest possible width. So this time I'm going to put 20.5 times 5.25 in my calculator to give me the answer 107.625. And that is question 1 sorted. Question 10. I'm given a formula for f here, the square root of g over h. I'm given some information about g and about h. Now g is equal to 12.17 correct to 3 significant figures. Sorry, to 12.7 correct to 3 significant figures. So the upper bound is 12.75 and the lower bound is 12.65. H, meanwhile, is given as 9.294 correct to 3 decimal places. So that's going to be an upper bound of 9.2945 and a lower bound 9.2935. Right, by considering bounds, work out the value of f to a suitable degree of accuracy. So on the left-hand side, I'm going to work out f, the highest possible f, work out the upper bound of f. And on the right-hand side, over here, I'm going to work out the lowest possible f. And then we'll see where that gets us. So on the left-hand side, working out the highest possible f, I'm going to want the highest possible numerator and the lowest possible denominator. So the square root of g, I'm going to use the upper bound of g, so that's going to be the square root of 12.75. I'm going to divide it by the lowest possible h to give me the highest possible value for f. So let's just work that one out. So I'm going to use my fraction and then square root on the top, square root of 12.75, and on the denominator I'm going to go 9.2935. Okay, and that gives me 0.384216, and so on. Now let's work out the lower bound for f. Let's do that over here. Obviously it's still going to be the square root of g over h, but I'm going to use the lowest possible value of g and the highest possible value of h, because that's how I'll get the lowest possible value of f. Lowest possible value of g is 12.65, so I'm going to have the square root of 12.65 over the highest possible h, 9.2945. Okay, put that in my calculator. Use the fraction, square root on the top of the fraction, 12.65, and on the denominator 9.2945. That gives me 0.382664. Right, let's have a look at these answers here. So I've got the upper bound of f on the left and the lower bound of f on the right. If I work to 1 decimal place, then the upper bound on the left is 0.4 and the lower bound on the right is also 0.4. Look at that, so that's good. What about if I push it to 2 decimal places? Will I get the same in both cases? Well, on the left-hand side, the upper bound, I get 0.38. And on the other side, look at that, I get 0.38 as well. So I can go to 2 decimal places. Can I push it to 3? On the left-hand side, to 3 decimal places, that would be 0.384. And on the right-hand side, I get 0.38, not 2, because it would round up to 3. But they ain't the same, are they? So I can go as far as 2 decimal places. So work out the value of f to a suitable degree of accuracy. Well, f is 0.38, and my suitable degree of accuracy is 2 decimal places, because if I go any further, I end up with different answers for my lower and upper bound. And that is question 10 sorted out. Okay, so in this question, we've got to find the equation of a line. Now, if we're going to find the equation of a line, I'm instantly thinking that I need to know the gradient of the line and also a point on the line. Right, now the equation of the line that I've got to find is perpendicular to this line here. It's perpendicular to the line 5y equals 2x minus 4. So if I can find the gradient of this blue line, which I'm going to do by dividing left and right by 5. So the gradient of that blue line is the coefficient of the x, 2/5. Then I can find the gradient of the green line. The gradient of the green line will be the negative reciprocal of that, because the green line is perpendicular to the blue. So now I know that my green line has got the equation y equals minus 5 over 2x plus c, and I simply have to work out what c is. I've got a point on the line. This green line goes through the point 0, 7, which tells me that its y-intercept is 7. So the equation of this line is going to be y equals minus 5 over 2x plus 7. Question 5. Right, the last question on this set. Well done for making it this far. So I've got a line L. Okay, fine. It's got that equation. I've got a line M that goes through 2 points. Okay, and I know that L and M are perpendicular, so I know something about their gradients there. Work out the value of K. Well, we're going to use the information we have about the gradients of these lines. So let's first of all concentrate on line L, which has this equation, and let's work out the gradient of this line. So I'm going to add 6x to both sides and divide by 4. 33 over 4 plus 6 over 4x. So the gradient of my line L is 6 over 4, which, by the way, is 3 over 2. So I know the gradient of L now. Let's have a think about line M. Well, I know the gradient of line M now, because it's going to be the negative reciprocal of 3 over 2. So the gradient of the line M is minus 2/3. I've got 2 points on the line M here. I've got the point A, which is 5, 6, and the point B, which is minus 4, k. So I'm going to use the 2 points I know to set up an equation for the gradient of M, because I know that that's equal to this. So let's have a look. The gradient here, well, I've got to do the difference in the y coordinates. Let's do 6 minus k divided by the difference in the x coordinates, 5 minus 4. Be careful of your sign. So the gradient is 6 minus k over 9. And I know that the gradient, 6 minus k over 9, is equal to minus 2/3. So there's an equation with just k in it. So I can solve that to find k. Multiply both sides by 9. Gives you 6 minus k equals minus 6. Subtract 6 from both sides. Minus k equals minus 12. So k is 12. Now let's just see what the question asked me to do. It asked me to work out the value of k, and I've done that. K is 12. And that is the end of question 5. Question 2. Right, the diagram shows a shape made up of 3 semicircles enclosing a right-angled triangle. Okay, now the straight lines here, the edges of the triangle, are each a diameter of this semicircle, and you know that this length is 6 and this length is 6. Okay, we've got to work out the perimeter of the shape. Right, well, first of all, I think I can work out this length here and also that length.
because each of those blue lengths there is half a circumference. So the circumference of the circle is pi times the diameter. And the diameter is 6, pi times 6. And each of those is a semicircle. So I could do one of the semicircles plus another of the semicircles. Or I could just imagine that both of those semicircles together make a circle. And I could just do the circumference of the whole circle. It doesn't matter whether I use this or whether I do half of it plus another half of it. That's those blue highlighted lengths sorted. Now the only other part of the perimeter of the shape is this yellow semicircle here. Now how am I going to find the length of that? I really need to know its diameter. So I really need to know this length here, the length AB. Now I can find AB because I can use Pythagoras on that right angle triangle. So AB, which is the diameter of my circle, I'll call it D. So the diameter of the circle there is going to be the square root of 6 squared plus 6 squared. So that's the square root of 72. So now I know the diameter of the circle is the square root of 72. So that yellow highlighted semicircle is going to have a length of pi times the diameter, but of course it's only a semicircle, divided by 2. So now I need to write an expression for the perimeter of the whole shape. So the perimeter of the whole shape is going to be the blue semicircle and then another blue semicircle plus the yellow semicircle. And that's what I need to work out. And if you put that in your calculator, carefully does it, you get the answer 32.17 and so on. And we're asked to give the answer correct to 1 decimal place. So my answer is going to be 32.2 centimetres. Question 3. Right, the diagram shows 4 identical circles. Yes, it does. Drawn inside a square. Yes. Each circle touches the other 2 circles and the 2 sides of the square, just like it's drawn in the diagram. The region inside the square that is outside the circles, the shaded region, has a total area of 40. Work out the perimeter of the square. Give your answer correct through significant figures. Right. So I'm given no measurements at all, except I do know that that shaded area equals 40. Right, well, I've got to start somewhere. So I'm going to start by assuming that the square has side lengths of x. And now I'm going to develop an expression for the shaded region and set that expression equal to 40. Because the information I'm given is about the shaded region equaling 40. So let's get an expression for the shaded region and set it equal to 40. Right, an expression for the shaded region. Well, let's have a think. If I assume that the square has side lengths of x, then the radius of one of those circles is going to be a quarter of x. Okay, right. So the shaded region then, shaded region is going to be the area of the square, which is x times x, minus 4 circles. Well, the area of one of the circles is pi r squared, so that's pi times x over 4 squared. So I just want to take away 4 of those, so 4 times pi times x over 4 squared. So there's an expression for the shaded region. Let's just recap that. It's the area of the square, subtract 4 circles. Okay, right. That's the shaded region, and I know I can set that equal to 40. So my equation then for x is going to be x squared minus 4 pi x over 4 squared equals 40. All right. Well, I better get solving, I guess. So I'm going to x squared minus 4 pi. Right, if I square x over 4, I get x squared over 16 equals 40. Right, I can simplify here and here. Okay, so that's going to give me x squared minus pi x squared over 4 equals 40. Let's multiply everything by 4. 4x squared minus pi x squared equals 160. Now I've got to solve this for x, so the secret is going to be I'm going to factorize it and divide. I'm going to FAD here, factorize and divide, because you see how you've got x squared in both of these expressions. So I'm going to factorize, take out the x squared, 4 minus pi equals 160. So therefore, x squared equals 160 divided by 4 minus pi. Okay, so now I can find x. So 160 over 4 minus pi, I'll put that into my calculator and square root it. On my calculator, when I put 160 over 4 minus pi in, I get about 186. So I'm going to square root that to give me x equals 13.65. Right, so I found x, I found the length of the square, the length of the side of the square. Square is 13.65 by 13.65. Now what's the question ask me? It asks me for the perimeter of the square. So the perimeter of the square is going to be 4 times 13.65. So 4 times 13.65 on my calculator is 54.61. And so, correct to 3 significant figures, my answer is going to be that the perimeter is 54.6. That is question 3 done.
Question 1. Right, the diagram shows parts of 3 regular polygons, A, B, and C, meeting at a point. Look at that, the polygons meet there. And I see that's part of polygon B, this is part of polygon C, and this is polygon A. Polygon B has n sides. Work out the value of n. So I'm being asked how many sides polygon B has. Polygon B is this one, isn't it? Right, well, I wonder if I can work out the interior angle here of B. Work out that 7x. It'd be nice to be able to work out what x was. Now I see all of those, the whole angle here altogether. Let me show you that. This whole angle from here all the way around, from here all the way around to there, is 360. And I also see that that's 18x. So I know that 18x is equal to 360. So if I divide both sides by 18, then I know that x is equal to 20. So now I can work out that the interior angle of B is 7 times 20, 140. Now I know the interior angle is 140, so I know the exterior angle is 180 minus 140, 40. And of course the number of sides is 360 divided by the exterior angle. So polygon B has 9 sides. It's a nonagon. And that's question 1 finished. Question 11. Right. B, C, D, E, F, G. That's this shape here. That shape there is a hexagon. It's got 6 sides, and we could count those to check, but I'm sure they're right. And then it tells you that AB, BC, and CD are 3 sides of a regular n-sided polygon. I'm sure that's supposed to say n-sided there. Okay. So those 3 sides are part of a polygon. Okay. I need to find the number of sides of the polygon and calculate the value of n. If only I could find the interior or the exterior angle of that polygon. There's quite a tempting interior angle of my mystery polygon there, isn't there? So I'm wondering if I couldn't find this red angle, because that would enable me to find the green angle. How can I find the red angle? Well, the answer is that the red angle is one of the interior angles of the hexagon. It's one of the interior angles of this blue hexagon here. Now, I've been given lots of angles of that blue hexagon, except actually that angle at C. So why don't I work out that angle at C, and then I can do 360, take away that angle at C to get my green angle. Let's have a look. So it's a hexagon, isn't it? So the total number of degrees in a hexagon is the number of sides minus 2 times 180. Sorry, the number of sides minus 2 times 180. So that's going to be 4 times 180, 720. So this angle here at C is going to be 720 minus the other interior angles. So minus 57, minus 104, minus 149, minus 95, and minus 90. So that angle is going to be 720 minus 57 minus 104 minus 149 minus 95 minus 90. That angle is 225. So that means that this green angle here is going to be 360 minus 225, 135. So the interior angle of my shape there is 135. So the exterior angle is going to be 180 minus 135. Okay, so the exterior angle is 45. So now I know the exterior angle of that shape. I can find the number of sides by doing 360 divided by the exterior angle. Let's have a look. 360 divided by 45. It's got 8 sides. It must be an octagon. And the answer is that n is 8. And that's question 11 done.
A bag contains only pink sweets, white sweets, green sweets, and red sweets. The table gives each of the probabilities that when a sweet is taken at random from the bag, the sweet will be green or the sweet will be red. The ratio of the number of pink sweets to the number of white sweets is 2 to 1. There are 28 sweets in the bag. Work out the number of white sweets in the bag. Well, so far I know that I have got 0.55 of the probability accounted for, because the probability of green or red is 0.2 plus 0.35, which is 0.55, which means that pink and white together must add up to 0.45. Now I know that the number of pink sweets is twice the number of white sweets. So I know that this probability has to be split up in the ratio 2 to 1, which has a total of 3. Okay, so I've got to split up 0.45 into 3 shares. 0.45 divided by 3 is 0.15. So that will mean that the probability of pink will be twice that, 0.3, and the probability of white will be 0.15. Probability of pink, 0.3. Probability of white, 0.15. Now, what does the question actually ask me? It says there are 28 red sweets in the bag. So 35% of the sweets is 28 sweets. Now I'm being asked for how many white sweets there are in the bag. So what's 15%? Well, if 35% of the sweets is 28, then I can do 28 divided by 35 to get 1% of the sweets, times by 100 to work out that there are 80 sweets in the bag in total. And then I know that 15% of those, so 12, are white,
which is what the question asks me. Work out the number of white sweets in the bag. Answer, 12 white sweets. There are 20 glasses in a cupboard. 13 are large and 7 are small. Roberta takes at random 2 glasses from the cupboard, so there's no replacement here. Complete the probability tree diagram. Well, when he first steps up to the cupboard, he has a probability of 13 out of 20 of taking a large one, and 7 out of 20 of taking a small glass. Now let's imagine that he takes a large glass. So we're here now. What's the probability of him then taking a second large glass? Or what's the probability of his second glass being small? Well, the probability of that second glass being a large, well, there are only 19 glasses left in the cupboard, aren't there? And 12 of them are large because he's already taken one large. And for similar reasons, there are only 19 glasses in the cupboard and 7 of them are small, so it's 7/19 the chance of that second glass being a small glass if he started with a large. Right, now let's come down here. If his first glass was a small, well, there are only 19 glasses left. And what about the number of small glasses? What about the number of small glasses there? Well, there aren't 7 left in the cupboard anymore. There are only 6. But of course, there are still 13 large. So that is the probability tree diagram completed. And now I'm asked the probability that Roberto takes 2 small glasses. So that's the probability of ending up here, isn't it? Small and then small. So I multiply the probabilities. So the probability of Roberta taking 2 small glasses will be 7/20 multiplied by 6/19. And so if I put that in my calculator, 7/20 multiplied by 6/19, I'm given the answer 21/190. Question 1. Let's get the x's equal and then we'll subtract the equation. So I'm going to multiply that top equation by 4. Gives me 4x plus 8y equals 60. Copy down the other equation, which has already got 4y in it. I'm subtracting the equations. Be careful, minus and minus is a plus. 14y equals 56. Use your calculator if you want to. Y equals 4. Right, now I'm going to look at this top equation to work out x. The top equation is x plus 2y, so that's x times 2 times 4 equals 15. So x plus 8 equals 15. So x equals 7. Now let's do the same with this second equation, 4x minus 6y. That's minus 6 times 4, because I think y is 4. And now we'll solve this equation and see if we also get x is 7 plus 24 to both sides. Divide by 4. Look at that. X is 7. So my answers are that x is 7 and y is 4. Question 1. Right, what I'm going to do is I'm going to use this expression for y here and substitute that into the second equation. So the equation is going to be x squared plus now y squared is 7 minus 2x multiplied by 7 minus 2x, and that equals 34. Right, let's multiply out those two brackets. 7 times 7 is 49. That's going to be minus 14x, and I'm going to have another minus 14x from here. Gives me minus 28x plus 4x squared from there. Equals 34. Tidy up the left-hand side. 5x squared minus 28x plus 49 equals 34. Now let's set that equal to 0 by subtracting 34 from both sides. Okay, there's a quadratic equation. Now, can I factorize that? Well, it's worth a try because I've got 5x squared, so that can only be 5x and x, and I've got 15 here, so possibly 5 3s. If I combine the 5 with the 5x, then that's 25, and 3 would make 28. and they're both negative. So my solutions to this equation are that either x equals 5 or x equals 3/5. Now what about y? Well, of course, I've got this equation here, haven't I? Y is 7 minus 2x. So if x is 5, then y is 7 minus 2 of those, 10, so that's minus 3. Or if x is 3/5, then y is 7 minus 6/5, which is 5 and 4/5. So my two solutions are that x is 5 and y is minus 3, or x is 3/5 and y is 5 and 4/5. And that's question 1. So we're asked to solve this equation to find the value of m. Now the first thing I'd do is I'd deal with this divided by 3 here. I'd seek to get rid of that, so I'd multiply the left and the right by 3. So on the left, I'd be left with 4m plus 9. And on the right, 3 times the right-hand side is 21 minus 6m. Now we've got an equation with with m's on both sides. We're going to see which side has the least m and get rid of them. Well, I've got minus 6m there and 4m there. So the right-hand side has the least. It has minus 6m. So to get rid of minus 6m, I'm going to plus 6m to both sides. So that gives me 10m plus 9 equals 21. Now this is looking more straightforward. I get a minus 9 from both sides to give me 10m equals 12, and divide both sides by 12 to give me m equals 1.2. We need to solve this equation to find the value of a. Now there are lots of different ways of tackling this. I'm going to do the subtraction on the left-hand side. So I'm going to write both of these fractions as being over 20. So I'm going to multiply the bottom of this fraction by 4, so the top of that one by 4. And I'm going to multiply the bottom of that one by 5, and the top of that one by 5. And then both of those fractions will be 20ths. So that's going to give me 4 times 9a, 36a minus 28 over 20, minus 15a minus 35 over 20, which is going to equal 4.55. So on the left-hand side, I have got all over 20 here, 36a minus 28 minus, and remember to put a bracket in here, 15a minus 35 equals 4.55. So what do I got on the numerator of my fraction? I've got 36a minus 28 minus 15a plus 35 all over 20 equals 4.55. So on the numerator here, I've got 21a plus 7 over 20 equals 4.55. Now I can multiply both sides by 20. So I'll have 21a plus 7 equals 4.55 multiplied by 20, 91. Minus 7 from both sides, 21a equals 84. And divide both sides by 21, a equals 4. And that's how I would solve that equation. Question 1. Right, we've got a function f defined as shown there, and we're asked to find the value of the function when x is 10. Or you might say we're asked to find f of 10, or you might say we're asked to f10, if you want to think about the function as being a verb. Now, the function is 2 times x over x minus 6, so that's going to be 2 times 10 over 10 minus 6, which is 20 over 4, so is equal to 5. Right, part B. Express the inverse function in that form. Right, well, I know that f of x is equal to 2x over x minus 6. Now, I'm always going to do this in the same way. I'm going to write y equals 2x over x minus 6, and now I'm going to make x the subject of this formula here, x the subject. So I'm going to multiply both sides by x minus 6. It's going to give me y, lots of x minus 6 equals 2x. Let's multiply out that bracket. Xy minus 6y equals 2x. Now I'm trying to make x the subject, so I'm going to put x, anything with an x in it, on the left, and all the other rubbish on the right. So I'm going to minus 2x from both sides, which is going to give me xy minus 2x. And I'm also going to add 6y to both sides, which gives me 6y on the right. Now, how am I going to make x the subject here? Well, the answer is, because x appears in both of those terms here, I'm going to factorise that. It gives me the left-hand side is x lots of y minus 2 equals 6y. And now you can see that you can make x the subject by dividing both sides by y minus 2. So, the inverse function, f to the minus 1 of x, is 6x over x minus 2. I've simply substituted x in there instead of those y's. Now in this question, it wants me to give it in this form. F to the minus 1 x is transformed to 6x over x minus 2. So I'll write the answer in here. And that is question 1 complete.
Question 15. I'm given the function f of x here, and I'm asked to f5. So if I'm going to f5, I'm going to do 3 times 5 minus 2. 15 minus 2 is 13. Right, part B. I'm given the function g of x. Ooh, look, there's a restriction there on the domain of g. And I'm asked to find the inverse function. So I'm going to start by copying down the function here. Okay, now find the inverse function. So I'm going to write y equals this. And now I'm going to make x the subject. To make x the subject, I'm going to need to complete the square because I've got a quadratic expression on the right. Now, when I complete the square, I really only want a positive single x squared. So I'm going to take 2 out of that expression there. 2 lots of x squared minus 10x. Close the bracket, copy down the plus 9. Now I've got a single positive x squared there. 2, open the square bracket. I'm completing the square on x squared minus 10x. So it's going to be x minus 5 squared, and that will give me x squared minus 10x plus 25, so I better minus the 25 away. Okay, and copy down the plus 9. So that gives me, multiply out this square bracket, 2 lots of x minus 5 squared minus 50 plus 9. Okay, so that is 2 lots of x minus 5 squared minus 41. Brilliant. Right, now I think I can make x the subject here. I'm going to add 41 to both sides and swap things around as well. So I've got 2 lots of x minus 5 squared equals y plus 41. Divide both sides by 2. X minus 5 squared equals y plus 41 over 2. Square root both sides. X minus 5 is either of the square roots of y plus 41. Add 5 to both sides, but write that at the beginning of the right-hand expression because that makes it easier. Okay, now I'm thinking that my inverse function is going to be 5 plus or minus the square root of x plus 41 over 2. But what was that restriction on the domain? X has to be greater than or equal to 5. So x can't be 5, subtract anything. So the only answer which is valid is 5 plus the square root of x plus 41 over 2. And that is that question complete. Question 1. Okay, I have got the adjacent here and the hypotenuse. I can see it's going to be cos. And I'm finding the adjacent, so the adjacent is going to be cos the angle multiplied by the hypotenuse. So x is going to be cos 42 times 9.5 on my calculator, and that's 7.0598. And so to one decimal place, the answer is 7.1. Question 3. All right, let's have a look. So we've got a semicircle with a triangle ABC inside it. Okay, A, B, and C are points on the semicircle. AB is the diameter, right? And then I've got some angles and some lengths, all of which are labelled on the diagram. Work out the perimeter of the semicircle. So I'm going to need to know that length plus that length. That's the perimeter of the semicircle. Now, let's see if we can work out the first of those first. Work out that red length there. That's the diameter of the semicircle as well, isn't it? Okay, what I'm looking at here is I'm looking at this length here, and I'm thinking, how can I work out that length? Let's have a look. It's part of that right-angled triangle, so let's draw the right-angled triangle up here. Not the best drawing in the world. That's the right angle there at C. That's A, that's B, that's 18, and this is the length I'm trying to find. Now, the length I'm trying to find is the hypotenuse there, isn't it? Okay, and I'm also given the 18 the adjacent. So I'm going to be using cos, and the hypotenuse x is going to be the adjacent 18 divided by cos 50. Okay, well, 18 divided by cos 50 gives me 28.003. So that is this length here, 28.003. Now, I also need to find, if I'm going to find the perimeter of the semicircle, I need to find this blue length here. Well, that blue length is half a circumference, isn't it? So the length of that arc is going to be, the circumference of a circle is pi d. So it's going to be pi d divided by 2. Now, what's the diameter of the circle? It's 28.003. So the arc is going to be pi times 28.003 over 2, whatever that is. So the whole of the perimeter of the circle is going to be the arc, which obviously I can work out on my calculator, plus this length here, 28.003. So that's the perimeter of the semicircle, which works out to be 71.99. Now it asks me for the answer correct to two significant figures. So the answer that I'm going to give is 72 centimetres for the perimeter of the semicircle. Question 2. The table shows information about the speed of 60 cycles. So I'm expecting there to be 60 cycles altogether. Complete the cumulative frequency table. Right, well, going between 0 and 10 is 3 of them. And then going between 0 and 20, well, that's going to be all of those. The 3 and the 16 makes 19. Keep on adding up. 19 and 24 is 43, then 53, then 58, and then 60. Good, so I do have 60 bikes, which are going between 0 and 60. So there's my cumulative frequency table. Right, on the grid, draw a cumulative frequency graph for your data. Right, I'll do the first point on the film, and then you can pause the film and do yours, and I'll do mine, and then you can press the film again, press play again, and magically I'll have done them all. Just remember that you plot against the end of the class. So I've got a speed of 10, and I'm going to plot 3 for my cumulative frequency against a speed of 10, because there are 3 that are going up to 10. Let's just do one more. I'm going to plot a speed of 20 for my cumulative frequency of 19. So speed of 20, cumulative frequency of 19. Right, my suggestion is you pause the film and plot your points, and then press play, and miraculously I'll have plotted mine too. Right, so there are my points plotted. So now I'm going to complete my cumulative frequency graph by carefully drawing a smooth line, a smooth curve through my points. Right, use your graph to find an estimate for the interquartile range of the speeds. Right, now I've got 60 bikes in all. Now the 30th one, that would be the median. I'm not interested in that because I'm after the interquartile range. So I'm going to want to know the speed of the 45th bike. And I'll also want to know the speed of the 15th bike. Then I'm going to find the difference between those two. So to find an estimate for the speed of the 45th bike, I need to draw a line across from here and then a line down. And then I need to read off what that speed is. So for me, the 45th bike is going at 32 miles an hour, and I'll need to subtract the speed of the 15th bike. So again, let me zoom this up a bit. So again, I'm going to draw a line across here, and then a line down here, and read off that speed. Well, for me, that's 17. So my interquartile range is 32 minus 17, which is 15. So the difference in speeds between my lower quartile and my upper quartile is 15 kilometers an hour. And that is the end of question 2. Example. This table shows information about the frame size in centimeters of 60 bicycles sold in a shop. Now, this is called grouped data because you can see that the different bicycles have been sorted into groups. Look, here are 4 bicycles, which have a frame size of between 30 and 36. So our bicycles, or our data, has been sorted into groups. Hence, it's called grouped data. Right, first question here is write down the modal class. Now, let's just take a moment to understand the table here. We've got 60 bicycles. Look, 4 of them are here, 14 here, 18 here, 19 here, and 5 of them are quite large. They've got frame sizes between 54 and 60. So I imagine that gives me my 60 bicycles overall. Now, if you've understood the table, then with luck, you can identify which the modal class is, which is the most common class, which of these groups has got more bicycles in it than any other. And of course, the modal class is from 48 to 54, because that's got 19 bicycles in it, rather than fewer bicycles, which are in all the other groups. Now, work out an estimate for the mean frame size. Now, this is dead common. Let's sort it out. What we're going to do here is we're going to use a method called mid-mad. Right, mid-mad. What we're going to do first is we're going to find the midpoints of each of these classes here. Because the thing is, these 4 bicycles, which are in the first group, we don't know whether their frame sizes is 30 or 31 or 32 or 33 or 34 or 35 or 36. Well, we know then it's not 30 because it's a harsh inequality. But anyway, we don't know exactly what the frame size is of those 4 groups. So we're going to assume that each of those bicycles has a frame size of 33. Why have I chosen 33? Because 33 is the midpoint of 30 and 36. Similarly, we're going to assume that these 14 bicycles here each have a frame size of, what's that going to be? 39, the midpoint of 36 and 42. Incidentally, if like me you have a bit of a blank and you think, crikey, what's the midpoint? What's the midpoint of 42 and 48? What you can do is you can add together the 2 numbers and divide by 2. So the midpoint there is 45, and the midpoint here is 51, and the midpoint here is 57. So we've done the first half of our mid-mad. We've written down the midpoints. Now the M stands for multiply. And I'm going to multiply the 33 by the 4. 33 times 4 is 132. That is the total frame sizes of those 4 bikes, 4 times 33. Right, I'm also going to do 14 times 39, or 39 times 14. You have to do a lot of calculator button pressing here. 45 times 18. 51 times 19. And 57 times 5. So I've multiplied, there you are, and now I'm going to multiply, the A stands for add. I'm going to add up all these frames. This is going to give me the total of all the frames of all the bicycles. And now I'm going to divide, because I've got that total, 2742. That's every one of the 60 frame sizes added up. And to find the mean, I'm going to divide that total by the number of bicycles there are, which in this case is 60. So that gives me an answer for the mean of 45.7 centimetres. So let's just run through that again. Mid-mad, find the midpoints, multiply, for instance, 33, multiplied by 4 gives you 132. Add to get your total, and then divide to find the mean. That is the first type of really common question which appears in IGCSE papers.
Okay, question 1. Now, throughout these questions, I am unashamedly going to use the rules of indices. So now that we understand the rules of indices, and if you're not sure of any of them, I suggest you watch the earlier parts of this film, then we can simply get on and use them. So in this case, I'm dividing. I'm going to subtract the powers, e to the power of 4. Part B, I've got y squared, which I'm raising to the power of 8. So that's going to be y to the power of 2 times 8, y to the power of 16. Part C, I'm raising this expression here to the power of 3. So I'm going to have 3 cubed, which is 27. X squared raised to the power of 3. 2 times 3 is 6. So x to the power of 6. Y to the power of 5 cubed is y to the power of 5 times 3, 15. And part D, I need to write this fraction in the form y to the power of b. So essentially, I need to write this fraction as y to the power of something and see what that something is going to be. Let's have a look. The top of the fraction is the fourth root of y, so that's y to the power of a quarter, and that's over y. Now, that means y to the power of a quarter divided by y. When I divide, I subtract the powers, and this is y to the power of 1 here. So my answer is going to be y to the power of a quarter divided by y to the power of 1 is y to the power of 1 quarter minus 1. So y to the power of minus 3 quarters. And that is question 1 complete. Question 24. Express x in terms of n. Right, let's see what we've got here. We have got 18 multiplied by the square root of 27 to the power of 4n plus 6 over 6 times 9 to the power of 2n plus 8, and that equals 3 to the power of x. Okay, well, let's simplify the left-hand side, shall we? So on the top, now 18, that's 2 9s. So I'm going to write that as 2 times 3 squared times square root of 27. Well, 27 is 3 cubed. So what I've got here is I've got the square root of 3 cubed, and that's being raised to the power of 4n plus 6. Okay, meanwhile, the bottom here, 2 times 3 times 9 is 3 squared, so I've got 3 squared being raised to the power of 2n plus 8. Okay. Right, what shall I do next? Oh, well, I can divide top and bottom by 2. So that's easily done. Okay. I really dislike crossing out, but never mind. I've divided top and bottom by 2. I'm going to leave the 3's as they are. I mean, I know I could do some simplification, but I'm not going to. So on the top, I've got 3 squared. 3 squared times. Now, square root of 3 cubed is
3 cubed to the power of a half. You'd multiply those, so it's 3 to the power of 3 halves. So I've got 3 to the power of 3 over 2, which is being raised to the power of 4n plus 6. And on the denominator there, I've got 3 times, now 3 squared, raised to the power of 2n plus 8. Remember your rules. It's going to be 3 to the power of 2 times 2n plus 8. So that's going to be 3 to the power of 4n plus 16. Okay, right, let's continue with this simplifying. So I have got on the top, still 3 squared, times. I've got 3 to the power of 3 over 2, which I'm raising to the power of 4n plus 6. So I'm going to multiply 3 over 2 by 4n plus 6. So that gives me 3 to the power of 6n plus 9. And that is all over 3 to the times 3 to the power of 4n plus 16. Okay. Right, well, I can simplify the top here just by adding these indices, can't I? I can do 3 to the power of something times 3 to the power of something else. Add those indices, I'm going to get 3 to the power of 6n plus 11. And on the bottom here, in the same way, I'm going to have, that's a 3 to the power of 1. So then I'm going to add the indices. So I'm going to have 3 to the power of 4n plus 17. Okay, now let's just go back to the beginning of the question. All of this, I'm trying to get it in the form of simply 3 to the power of something. Now, I've got 3 to the power of 6n plus 11 divided by 3 to the power of 4n plus 17. So I'm going to subtract those powers. But of course, I'm going to be very careful. So I've got 6n plus 11 minus, put that in a bracket so I don't mess up the signs. So that's going to be 3 to the power of, let's write that 11 a bit more legibly. I'm going to have 6n minus 4n, so that's 2n. Then I've got plus 11 minus 17 plus 18. So that is what the left-hand side boils down to, and that equals 3 to the power of x. So that tells me that x must equal 2n plus 18. Now let's just go back to the question. It says express x in terms of n, and that is what I've done there. So that is question 24 sorted. Here are the first 5 terms of a linear sequence. Now I see already that the sequence goes up in 4s. Write down the next 2 terms of the sequence. Well, that's going to be 27 and 31, adding 4 each time. Give the term-to-term rule for the sequence. Well, add 4 to each term to obtain the next term. Write down a formula for the nth term of the sequence. Right, well, in this case, I'm going up in 4s. So my nth term formula is going to be 4n. Now, if it were 4n, then the first term would be 4 times 1, 4, and my first term is 7. So I need to have 4n plus 3. So that is the formula for the nth term of the sequence. Pause the film now to do the question before me. So the sum of the first 48 terms, as 48, is given by 24 multiplied by 2a plus 47, n minus 1, d. And in the same way, the sum of the first 36 terms is 18 half of n multiplied by 2a plus 35, d. And we know that the sum of the first 48 terms, 24 lots of 2a plus 47d, is equal to 4 times the sum of the first 36 terms. Okay, so I've got an equation there with a's and d's in it. I'm going to multiply out
both sets of brackets to give me 48a plus 1128d equals 144a plus 2520d. Rearrange that. Minus 96a on the left equals 1392d. And so a is minus 14.5 times d, dividing both sides by 96. Now we're asked to find the sum of the first 30 terms. And the sum of the first 30 terms is given by the formula S30 is 15, 30 over 2, multiplied by 2a plus 29d. Let's substitute our expression for a into this formula. We're going to have 15 multiplied by 2 times minus 14.5d plus 29d. Let's continue to simplify that. That's 15 times minus 29d plus 29d. Well, that's 15 times 0. So the sum of the first 30 terms is 0. Expand and simplify. X plus 2 times x minus 5. Right, well this time I think I'll use what some people call the crab claw method, and I'll draw out the top crab claw there and the bottom crab claw here. So looking at the top, I've got x times x squared, x times minus 5x. And looking at the bottom, I've got plus 2 times x and plus 2 times minus 5. So that's it expanded, and now I must simplify it. X squared minus 3x minus 10. Expand and simplify. Now, I've got 3 brackets to expand here. I always do these two first. So I'm going to have my 2x plus 1, and now I'm going to expand those 2 brackets. So I'm going to go x times x times minus 5, 3 times the x, and 3 times the minus 5. So what I've got here is I've got 2x minus 1 multiplied by x squared minus 2x minus 15. Right, let's just write that down so I've got a bit more room. 2x minus 1 multiplied by x squared minus 2x minus 15. So what I'm going to do now is I'm going to do 2x multiplied by each of those items in the second bracket, each of those expressions in the second bracket, and then I'm going to do minus 1 multiplied by each of those expressions in the second bracket. So 2x multiplied by x squared, 2x multiplied by minus 2x, 2x multiplied by minus 15, and now minus 1 times x squared, minus 1 times minus 2x, and minus 1 times minus 15. So that's expanded, so now I must simplify that. I've got 2x cubed minus 4x squared minus another x squared minus 5x squared minus 30x plus 2x minus 28x, and then plus 15 at the end. Question 2. Factorize this. Right. X and x multiply to a minus 24, but we'll need to end up with the plus 5x's. So multiply to 24, 8 and 3 plus the 8 minus the 3. Hence, solve this. Set it equal to 0, that's already done. Factorize the left-hand side. Well, I've already worked that out, of course. So my answers are x equals minus 8 or 3. Question 10. Write down the solutions to this equation. Right. I need to find the value of x, which will make the first bracket equal 0. Well, that is going to be x is minus a half. I need to find the value of x, which will make the second bracket equal to 0. Well, that is going to be minus 4 over 3. And I need to find the value of x, which will make the third bracket equal to 0? Well, that's simply x is 5. So my three possible values of x are minus a half, or minus 4 over 3, or 5. Okay. Solve this equation. Show you're working clearly. I'm going to set it equal to 0 by minusing 1 from both sides. Now, it doesn't say give your answers to 3 significant figures or anything like that, so it's not saying I've got to use the formula. I'm going to try and see if I can factorise it. Now, if I can't factorise it, I'll just use the formula. Or maybe you've chosen not to try and factorise it, just to use the formula straight away. That's up to you. But look at this. I know it has to be 3x and 1x to give me the 3x squared. And I've got a minus 1 here. Well, that kind of has to be a plus 1 and a minus 1. So it could be plus 1 and minus 1, or it could be minus 1 and plus 1. Okay, so one of these is going to be the correct factorisation. I just need to have a look at them and see which one gives me the plus 2x. The answer is the second one gives me plus 2x. So I'm going to get rid of that one. That's it factorised, and so my two solutions are x equals a third or minus 1. But you could have got those same solutions by using the formula, and that would be fine. Okay.
Question 1. Right, I've got the numbers from 1 to 14 shown in the Venn diagram. There they are. And I need to list the members of A intersection of B. That's going to be these 4 numbers here, which are in A and B. They're in the intersection. So my answer is simply 2, 4, 6, and 12. Right, part B. List the members of the set not B. So these are going to be all of those that are not in B. So these ones are not in B. Okay, and anything out here is not in B as well. So there is everything shaded that is not in B. So my answer is going to be 8, 14, and 10. And also 9, 13, 11, 7, and 5. That's everything that is not in B. Okay, a number is picked at random from the Venn diagram. Find the probability that this number is in A but not in B. So to qualify, the numbers need to be in A but not in B. So these are the numbers which are in A but not in B. These numbers here, they don't qualify. Okay, they're in A, but they're also in B, so they don't qualify. So the numbers which are in A and not in B are those 3 numbers. So the probability that I choose a number which is in A but not in B is going to be 3 out of how many numbers are there altogether in the Venn diagram? There are 14 numbers. So the probability is 3 out of 14. And that's that question finished. Question 3. 100 farmers, don't forget about that piece of information, are asked if they have goats, sheep, or chickens on their farms. Of these farmers, and here's a whole load of information. Using this information, complete the Venn diagram to show the number of farmers in each appropriate subset. Okay, all right. This first piece of information says 31 have sheep. It would be really tempting just to write 31 there, but that wouldn't be correct, because here, those are the farmers who have sheep only, who don't have any goats or chickens as well. So you'd be wrong to write 31 in there. When it says 31 have sheep, that means that this section, this section, this section, this section would all add up to 31. So 31 have sheep isn't useful to me at the moment, and nor is 53 have chickens. 6 have goats, sheep, and chickens. That is useful. I can write a 6 in there. 11 have sheep and goats. Right, it would be tempting to write 11 in here, but if you were to write 11 in here, that would mean that 17 have got sheep and goats, and that isn't correct because only 11 have got sheep and goats, so that must be a 5. Right, I can tick that off. 17 have sheep and chickens. Sheep and chickens. Here we are, 17, so 11. have sheep and chickens because 6 have sheep, chickens, and goats. So they also have sheep and chickens. 18 have goats and chickens. Goats, chickens, I've already got 6 of them, so 12 must be there. 20 do not have any goats, sheep, or chickens. They go here. Right, well, I haven't filled in everything yet, but let's go back to the beginning, shall we? It says 31 have sheep. So that means that there has to be 31 in here altogether. Well, I've already got 22 of those. So if 31 are in there in total, then there must be 9 here. Good. 53 have chickens. Well, that means that all of these numbers here must add up to 53. Well, I've already got 18, 28, 29 of those, so I'll have to do 53 minus 29, 39, 49, 14. There we go. So 14 comes in here. So now these numbers do add up to the 53 who have chickens. Well, I seem to have used all the information here. I've ticked off every statement, but I've still got some blanks. I've got a blank here. And this is where you have to be very sure that you've used all the information, because I haven't yet used this piece of information at the beginning, that there are 100 farmers in all. So I know that all the numbers in the Venn diagram have to add up to 100, which is going to enable me to work out the number of farmers who have only goats, this number here. So what have I got so far? 5 and 9, 14, 20, plus the 12 is 32. 32 plus 11 is 43, 53, 57, 77 so far. So 100 minus 77, there must be 23 who have just goats. Now I have completed the Venn diagram and I've shown all the farmers in each of the subsets. Find the number of farmers who have goats. The number of farmers who have goats. Well, don't just write the 23, because that's the number who have only goats. There are actually 23 plus 5, 28, plus the 12 is 40. There are actually 46 farmers who have goats. Now what's going on here? Find the number, okay, which are not in G union S. Not in G union S. Well, here is G union S. Okay, and we want the number who are not in there. So the number that are not in there are the 20 and the 14. So 34. Okay, right. Now what about this last one? Find the number which are in not G and also in C. So to qualify for this, they have to be in not G and they have to be in C. Right, so let's have a look at the ones which who have chickens who don't have goats. Because the ones who have chickens, they're in C. So this lot are in set C. But we only want the ones of those who don't have goats. So we only actually want these ones. So the answer is going to be 25. Right. Okay. One of the farmers who has chickens is chosen at random. So we know we're dealing with these farmers only. One of those is chosen at random. Find the probability that this farmer also has goats. Well, how many of those also has goats? Well, the answer is that 18 of those also have goats. So it's 18 out of, how many farmers are we choosing from? 12 and 6 is 18, plus the 14 is 28, 32, 43. So 18 out of 43. Well, I can't simplify that. So that is my answer to part C, and that is question 3 done. Histograms, question 1. Right, we've got information about the age of 80 teachers. Always note what the information is about. It might be useful later. We've got to draw a histogram. So the first thing we're going to need is we're going to need the class width. So 20 to 30, that's a width of 10, 30 to 35, 35 to 40, 40 to 50, and 50 to 65 is a width of 15. Now we're going to need to work out the frequency density. Now remember, the frequency density is the frequency divided by the class width. So 20 divided by 10 is 2. 20 divided by 10. Okay. 22 divided by 5 is 4.4. 16 divided by 5, 3.2. 13 divided by 10, 1.3. And 9 divided by 15, 0.6. So it's the frequency densities that we're going to plot looking at this y-axis. I'm going to label that axis frequency density. And I'm going to label this axis age. Now, my age has got to go from 20 to 65. So looking at along here, I'm wondering if it's going to work out to go 20, 30, 40, 50, 60. Yes, it will. So 20, 30, 40, 50, 60. And this, of course, would be 70. Now, the frequency density, I've got to go from 0 here. How far up have I got to go? I've got to get to 4.4 along here. So I'm thinking if I go 1, 2, 3, 4, 5, will that work? Yes, it will. Sometimes the most difficult bit is working out what scale to use. And now all I've got to do is plot the histogram. I'm not going to make you watch me do that, so I'll pause the film, plot it, and then I'll show you the finished result. So there is my finished histogram, and the only bits which were tricky really were getting the bars the correct width, and of course you can read that off the ages, and also some of these, for instance, when I plotted to 1.3, I had to be very careful when I read my scale here to make sure I plotted to the height of 1.3. That's question 1. Finished. Question 6. The histogram shows information about the weight of pigs. Okay, right. 30 pigs weigh between 50 and 65. So I know that this area of the histogram relates to 30 pigs. Work out an estimate for the number of pigs that weigh more than 80. Well, the first thing I need to know really is how many pigs weigh more than 80. If I look at this bar that I know, I can see that I could split it into 6 5 by 5 squares, which would mean that each 5 by 5 square would be worth 5, wouldn't it? Because 6 5s have 30. So now I can work out how many pigs there are in each of these bars. So this one is going to be 5, 10, 15, 20, 25, 30. So 30 pigs in this bar. 5, 10, 15, 20, 25, 30, 35, 40. Now, here we've got 5, 10, 15, 20, 25, 30, 35, 40. 5, 10, 15. Okay, so that's how many pigs there are in each bar. Now let's have a look at the question. Work out an estimate for the number of pigs that weigh more than 80. Right, so here's my 80, and I need to know how many pigs lie to the right of this line. Well, I know it's 15 in here, and I know it's half of that 40. So it's going to be 15 plus 20, 35 pigs. Explain why this is only an estimate. Well, you know for sure that 15 lie here. Okay? But what you don't know is how these pigs, the ones between 75 and 85, what you don't know is how these pigs are distributed between 75 and 85. So you're assuming that they're evenly distributed because this is grouped data, so you don't know really what those exact ones are. So I would say something like this is grouped data. Okay, so we don't know exactly how many pigs lie in that range, do we? So we don't know exactly how many pigs weigh 80 to 85 kilograms. Okay, and that is number 6 finished. Given that the surface area of a sphere
is 49 pi square centimetres. Find the volume of the sphere. Give your answer correct to the nearest integer. Well, here are the formulas for a sphere, which I've copied from the formula sheet on the front of your paper. And in this question, I'm told that the surface area of the sphere, so that's 4 pi r squared, is equal to 49 pi. So what I'm going to do is I'm going to use this information to find the radius of the sphere, and then I'm going to use the radius of the sphere to find its volume using this formula. So first of all, I've got the surface area of the sphere, 4 pi r squared equals 49 pi. Let's divide both sides by pi. So now I've got 4r squared equals 49. Let's divide both sides by 4. And let's square root both sides. So the radius of my sphere is 3.5. And now I'm asked to find the volume of the sphere. Correct the nearest integer. So the volume formula is 4/3 times pi times r cubed, and r is 7/2. So I'm simply going to put that into the calculator. So I've got 4/3 times pi times 3.5 cubed. And that gives me 179.59, so on. And so to the nearest integer, the volume of the sphere is 180 cubic centimetres. This is a fun question to finish on as it combines volumes of cones with scale factors. Let's have a look. Here is a frustrum of a cone. The frustrum is made by removing a small cone from a similar large cone. The height of the large cone is 15, that's marked on the diagram. The radius of the base of the large cone is 6. The radius of the base of the small cone is x. The volume of the frustrum is that. Work out the value of x. Right, well, let's first of all use this piece of information that we're given here. We're told the volume of the frustrum, that's the volume of this bottom part of the large cone, is that. Well, we know that the volume of the whole cone is, what is the volume of the whole cone? Well, the volume of the large cone, the volume of the whole cone, is 1/3 pi r squared h. Okay, well that's 1/3 times pi times 6 squared times 15. If I put that in my calculator, I get 180 pi. So I know the volume of the large cone, and I know the volume of the frustrum, so that means I can find the volume of the small cone. Okay, well if I can find the volume of the small cone, then I can look at the ratio of the volume of the small cone to the volume of the large. Then I'll have a volume scale factor, so I can work out a linear scale factor, and hence I can work out the relationship between the 6 and the x. Let's try that. So the volume of my large cone is 180, and the volume of the frustrum is that. So therefore, the volume of the small cone is the volume of the large, subtract the volume of the frustrum. Okay, so that's 180 pi minus 4212 over 25 times pi. So that gives me 288 over 25 pi. So now I know the volume of the small and the volume of the large. So here we go, volume scale factors. Let's have a look. So the volume of the large is 180 pi, and the volume of the small is 288 over 25 pi. So what is the volume scale factor? I like going from small to large, so I'm going to do 180 divided by 180 pi divided by 288 over 25 pi. So So the volume scale factor there is 125/8. So that means that the linear scale factor will be the cube root of that. Okay, so the cube root of that. So I want to know the cube root of the cube root of 125/8. Well, I could work that out in my head, really. Okay, so it's 5/2. So the dimensions of the small one, the dimensions of the small cone, are multiplied by 5/2 to give me the dimensions of the large cone. But the radius of the large is 6, so if I do 6 divided by 5/2, I will get the radius of the small cone, which is x, which is what I'm asked to find. So 6 divided by 5/2 gives me an answer of 2.4. So x equals 2.4. Well done for working your way through all of those questions. Have you got a question? Is there anything else I can help you with? Leave me a comment and I will respond. Are there any topics which you'd like some more help with? Leave me a comment and I will respond. Are there any topics which aren't covered in this film that you would like some more resources for? Leave me a comment and I will respond. Thank you very much for watching. See you in the next film.